Good morning, students. Now we are going to see the topic called transpose of a matrix. After you learn matrix, what is the meaning of matrix and matrix addition, subtraction, and multiplication. Now we are going to see transpose of a matrix. That is, for example, if A matrix A is this one, okay, how to find out A transpose? A transpose is denoted as A power T you can write, or else A dash you can write. Okay, so A transpose is nothing but writing the rows of a matrix A into columns. So rows you have to write it as column. So this row, if you write it as column 1 and minus 2, if you write it as column, you get like this, and second row you have to write it as column. So this is nothing but A transpose. Similarly, matrix B, and whose transpose if you want, B transpose if you want, then rows into rows you have to write as column. So 0 and 1 you have to write as column, and 2 and 4 you have to write as column 2 and 4. Similarly, for a matrix A, which is 2 4 0, you have to, for A transpose, you have to write it as 2 4 0 into column, and again 3 9 6 rows you have to write as column 3 9 6. Similarly, for B you can try, and for this sort of matrix, again row into column, second row second column, third row third column, like this you have to write. Okay, next we are going to see about once again, next we are going to see a note, that is AB, the whole transpose, you can write it as B transpose into A transpose. That is a proof for this one, and you can take any example also for matrix A and matrix B, find out the multiply, and then find the transpose of it. So it will be equal to B transpose into A transpose. You can check with any examples. Okay, and then this one, in matrix multiplication, I didn't teach you about this one. See, matrix AB multiplication need not be equal to BA. Matrix AB multiplication need not be equal to BA. In numbers only, we can say 2 into 3 is also 6, and 3 into 2 is also 6. But in matrix multiplication, we cannot say AB is equal to BA. Then about symmetric concept. What is meant by symmetric? When A is symmetric, right, we can say A is symmetric matrix if A is equal to A transpose. For that, we can take an example. The matrix A, diagonal elements you can write any elements, and the remaining element, if it is 3 here, you write 3 here, right? Then I can say this matrix is symmetric matrix. Why? It's transpose when you find out, A transpose when you find out. Rows you have to write as column, and 3 and 2 you have to write as column. Now you see both will be same. Okay, so this matrix A, we call it as symmetric matrix. And how to identify? By seeing the matrix itself whether it is symmetric or not. If you want to identify, close the diagonal, right? Close the leading diagonal and look at the upper part. If it is 3, the below one is also will be 3. So this will reflect over here. Okay, this 3 will reflect over here. Similarly, for 3 cross 3 also, all 3 elements will be over here. Those 3 elements will be reflected here. Okay, so this matrix, we are calling it as symmetric matrix because A is equal to A transpose. We can say A is skew symmetric matrix if A is equal to minus A transpose. This is the example of skew symmetric matrix. For a skew symmetric matrix, diagonals you take 0, a diagonal should be 0, and this element will reflect over here again, but sign wise difference will be there. If it is minus 3, there will be plus 3. If it is minus 3, there it will be plus 3. In such a way, if you take in an example, then you will get a skew symmetric matrix. Okay, now how it is skew symmetric we are going to see now. Suppose this is the example. Then A transpose, if you find out rows you have to write as column, this row you have to write as column, and then this A transpose, if you multiply by minus, you get this one. So 0 into minus 0, and this will become minus 3, and minus 3 will become plus 3. Now you see both these two, both are equal. I mean A is equal to minus A transpose. So we call this matrix A as skew symmetric matrix, since it uh, A is equal to minus A transpose. Okay. And by seeing itself, how to identify whether the matrix is a skew symmetric matrix is, right? For a skew symmetric matrix, diagonal will be 0, and when you close the diagonal, this element will reflect over here, but sign wise difference will be there. Okay. And then next topic, that is A plus A transpose is always symmetric. Why A plus A transpose is always symmetric is, you can take any example. Suppose A is any matrix, you can take 1 2 1 1, right? You just find out A transpose 1 2, and rows you write as column. Okay, and then you just find out A plus A transpose, add both. So by adding both 1 and 1, if you add, you'll get 2 and this one is 3, 1 and this one 3, and 1 and this one is 2. Now you can see A plus A transpose is a symmetric matrix, because by closing the diagonal, this element is reflected over here. It's here also 3, there also 3, or here also 5, there also 5. If you get like that, then this matrix is a symmetric matrix now. So always, if you take any matrix, for example, A plus A transpose is always symmetric. Similarly for A minus A transpose also. A minus A transpose is also always skew symmetric. Okay. Or you can take the same example, you find out A minus A transpose for this one. This minus that one, if you do 0, this matrix minus this matrix. So 2 minus 1 will become 1. 1 minus 2 will become minus 1, and 1 minus 1 will become 0. So A minus A transpose is this one, and you see it is a skew symmetric matrix. Right? By seeing, you can say it is skew symmetric matrix because this is minus 1 and that is plus 1, and the diagonals are 0. Okay. And another proof, that is this one, A is equal to once again, then about A minus A transpose is always skew symmetric, we have seen. Okay, and next we are going to see about this one. A is equal to 1 by 2 into matrix A can be written as always half of A plus A transpose plus half of A minus A transpose. How both will be equal is, if you multiply the 1 by 2 inside, right, this will become half of A, and here 1 half of A, both will become A, and this one into this is half of A transpose, this one into this one is minus half of A transpose, so both will get cancelled. So A, you can write it as half of A plus A transpose plus half of A minus A transpose. I think you are able to understand. And Harish, what do you say, whether you are able to understand or not? Harish, and then Karthikeyan, whether you are able to understand the concept. And what about Nitish? Today's may I know what is the dish today? Snacks. Snacks today. Then Nidhi, I'm very difficult to find out whether Nidhi is able to understand or not, because you show your face like that. Okay, understood. Fine. So, next, this is the board examination question. Express the matrix 1 5 minus 1 2, this one, which is the this one. Next, this is one board exam question. That is, express the matrix as symmetric and skew symmetric. Okay, and so express this matrix as symmetric and skew symmetric. See how to make this matrix as symmetric and skew symmetric is, you have to use this one. A is equal to half of A plus A transpose plus half of A minus A transpose. Okay, then what is A transpose? You just find out what is A transpose. A transpose is this, the given matrix is A, and this is A transpose. If you take rows, you have to write it as column minus 1 and 2. Now A is equal to half of this both the matrix. If you add, then it is A plus A transpose. If you add both, so it becomes 2, and this will become 4, and this will become 4 and 4 over here, and again half of A minus A transpose. Both if you subtract, so it becomes 0, and both if you subtract 6, this and this if you subtract, you will get minus 6, and 2, and this one if you subtract 0. Now A is equal to, if you divide by 2, 1, 2, 2, 2 you get, and this is you get 0, 3, and minus 3 and 0. So matrix A you have written as sum of symmetric and skew symmetric matrix. Because this is symmetric matrix, you can see this element reflect over here by closing the diagonal. Similarly, this is skew symmetric because diagonal elements are 0 and this element is reflecting over here, but sign wise there is a difference. Fine. So it's a board examination question. 1 year they asked in board examination. Then I hope you are able to understand this part. And next we are going to see about this one. This is the final question. This also 1 year they asked in board examination. This question: if A and B are symmetric matrices, then prove that AB plus BA is skew symmetric. Okay, so A and B are symmetric matrix they have given. That means you can write A is equal to A transpose, B is equal to B transpose, because they said A and B are symmetric matrix. Okay, then so how to prove this one? So you take, whenever they ask like this, by providing A and B are symmetric, you have to prove AB plus BA is symmetric. If they ask, you take the given matrix and its transpose. Given matrix and its transpose you write. Okay, so AB plus BA, the whole transpose, you can write it as this one transpose separately and this one transpose separately. Okay, and there is a proof just now we have seen in the note. AB the whole transpose, you can write it as B transpose into A transpose, plus again BA the whole transpose, order will be changed again. A will come first and B will be next. Then you know A is equal to A transpose, B is equal to B transpose. Substitute over here, B transpose is B, A transpose is A. Again A transpose is A, B transpose is B. So now what will happen? BA plus AB you got. This one order you can change now. AB you put here and BA you put here. Now see what's happening. This matrix is equal to this one. So that means this is the whole thing is one matrix. This whole thing is one matrix. It is equivalent to its transpose. This matrix is equivalent to its own transpose. Correct? So that means that matrix is, this matrix is symmetric matrix, because it is equivalent to its own transpose. Symmetric meaning is what? A matrix A is said to be symmetric matrix if A is equal to A transpose. Same thing is happened over here. AB plus BA is equal to AB plus BA the whole transpose. Therefore, AB plus BA is symmetric matrix. Thank you. I hope everybody are able to understand this, right? Okay, we'll see in the next session. Thank you.